Hello, this is Team UL Case from University of Louisiana Lafayette and Case Western Reserve University, and we will be discussing SpaceCube 3 Remix. Our team includes 2 professors and 2 PhD students, and with the combined years of experience more than 25 years, accomplishment of 110 articles, 16 patents, and 9 recognition awards. We have air vehicles everywhere from daily travels, even for the space operations. However, we may have sometimes some problems related to the flight, especially when there are some non-idealities, and it may have some catastrophic results. Following NASA's flight processor card and mini processor cards designed for resilient processing, which we will be dealing with control and memory systems, we will be dealing with a resilient system in addition on the top of those designs by making the data processing robust to problems during the flights. From ground to air, electronic systems can be vulnerable to any kind of non-idealities, from electromagnetic signals to severe conditions such as solar radiations, cosmic rays, alpha particles, which may cause some problems on the hardware systems. Especially the memory systems are much vulnerable to small changes, such as the bits that we save the data in terms of ones and zeros in the regular conventional memory systems. However, when we have a bit flip, which means 1 becomes 0 or 0 becomes 1s, can create some catastrophic results. The recent news 1 month ago, we have this problem for one company announced that there was the solar radiation problem, and then the memory related bit flips, with other words soft errors, caused some problems in their flight systems. Flight control systems can be affected with those kinds of bit flips, and this can be solved not only with the current proposals changing the hardware system, but also in the data layer by altering the representation of data as we propose with this work. The solution to bit flips known in the computer science is the stochastic and hyperdimensional computing emerging paradigms. We represent data in either scalar or some symbols in the random bit streams, which inherently robust to bit flips. For instance, if we have a value as 4, we have 4 logic 1s and the remaining 0, which means we have a randomly occurring 1s and 0s, which are robust to those bit flip errors. With this representation, arithmetic operations completely change to very simplistic operations such as AND and XOR gates that is very easy to implement in hardware. SC is robust to data flips, as in this example. In base 2 regular representation, if any flip happens in the important bit, then it may cause 2 over some values based on the position. But in SC, any bit position having the same significance. So when we have a flip, the value does not change that significant. And hyperdimensional computing help a lightweight and no error check learning model with a single pass learning, which beyond the simplistic operations brings some simple learning mechanism. Our proposed solution be built on the top of these 2 patents, and we propose using the Bitstream based data layer to representing all the scalars and symbols in the random bit streams, and then try to understand the anomaly detections and hardware helped by scoring on the streaming telemetry. Our business model include a partnership between 2 universities, and of course the NASA technology transfer. Resources will be from the 2 universities' research lab that we lead. We will be mainly developing a Bitstream resilient system as an main activity, and we will be dealing with the astronauts and the pilots. Our revenue will be including the per program or per unit licensing. We will be following per module valuing. So for the value proposition, we will be not replicating any full pipelines. Instead, we will be making some onboard analytics under radiation-induced bit flips. Thank you very much for your listening.